Hello, math students. We are starting Module 9 called Expressions and Equations, and this is Lesson 1, and Lesson 1 is called Generating Equivalent Expressions. Our goal for today we are going to use the commutative and associative properties to analyze and create equivalent expressions. The question that I want you to be thinking about during this lesson is, what are the mathematical operations that can be moved around, making the order of the expression not matter? So basically, this is a continuation of the lessons that we talked about in 6th grade when you were working with word math sentences and converting them into numerical math sentences, understanding vocabulary words, what they look like with symbols, and all of that kind of stuff. So this first section of our notes is basically a things to know section that talks about important vocabulary words. So the important vocabulary words that I need you to be aware of and you need to know how to use when working with expressions and equations are as follows. First one is a variable. An example of a variable is the letter X. It could be the letter T. It could be a symbol. Typically, we find the letter X as most variables used in most problems. The definition is a symbol that represents an unknown amount. The next one is an expression. And here's an example of an expression. An expression could be 1/2 times the quantity X plus 8. The reason that this is an expression is because it's missing the equal sign. So the definition of an expression is a number sentence that is unsolved with variables and no equal sign. The key word in there is unsolved because it cannot be solved. If it's truly an expression, it cannot be solved. It can be simplified, but it cannot be solved without knowing what it is equal to. So then that would turn it into an equation. Equivalent expression means that one set is equal to another set. So for example, in this example, this right here is an expression, and this right here is an expression, and they are equivalent because they mean the same thing. So 12y divided by 6 means the same thing as 2y. Okay, and so the definition that I want you to know is two expressions that equal the same quantity. A term is a part of the expression. That's the definition. And so in this specific example right here, we actually see 3 different terms. And the reason why there are 3 different terms is because the variables are different. So you will notice on one of them we have an X as a variable, on the other we have a Y as a variable, and then the third one has no variable at all, and so all 3 of those are 3 different terms, okay? And so a term is a part of an expression. Coefficient. A coefficient is the number that tells how many of the variable that you have. And so what we call that is the number that is being multiplied by the variable. The number that sits next to the variable that is being multiplied to. So the coefficient in this example is 2, because it is the number that is sitting next to the variable, and 6, because it is the number that is sitting next to the variable. And when it's sitting next to the variable, it's telling you I have 2 x's and I have 6 y's, and then I am going to subtract 3. 3 does not have a coefficient because it doesn't have any variable. So the key to understanding a coefficient is that it's the number being multiplied to the variable. Okay? The next one we have is expression in expanded form. So again, it's an expression, no equal sign. In expanded form, it means that your coefficient that you had is spread out. So this one would have been 2a plus 1b plus 3c. But in expanded form, you have to write it out. So you have a plus b plus c plus c plus c. So a math sentence that has been broken apart to see each term. Okay? The next one is an expression in standard form. An expression in standard form means that you identify how many you have of each and put a coefficient, and then you write it as condensed as you can get it. So I have 2a plus b, or you could put 1b, plus 3c, because we combine the terms that are alike and condense them down into simplest form. So an expression in standard form is the simplified final expression. So basically we took this one and we turned it into this one. Numerical expressions only have numbers. Okay, so 3 plus 6 is considered a numerical expression because it's only, the terms are only numbers. A math sentence with only numbers and no equal sign because of the expression. And then the value of numerical expression, it's when you actually have to solve it to figure out what does this value have. So if you have 12 and then you get rid of 4 of them, the value of this side is 8, and the value of 8 is 8, so 8 equals 8. So what does this expression value hold, or what does it mean? The answer to a numerical math sentence. So those are all vocabulary words that you have to be familiar with. I think that on some of them, they were definitely a review, so hopefully you were able to remember those things. All right, so continuing on with our lesson. The next part of our knowledge base acquisition is the properties. So commutative property, the property that allows you to change the order in which you add or multiply numbers. The thing that's the most important to remember is that the commutative property is only able to be applied when you add or multiply. Those are the only two operations that you can use the commutative property. And the reason for it is that if you change the order in which something subtracts, then you're changing the entire value. Whereas when you're adding, you're bringing everything together, so it doesn't matter how it came together. And multiplying, you're bringing everything together, so it doesn't matter how the order is. So looking at this, we have 5 plus 7 plus 3 plus 2. And on this side, we have 3 plus 5 plus 2 plus 7. So the question is, do they have the same answer? And then your other question that you have to answer is, are they equivalent expressions? So on this side, if we were to solve, then we know that 5 and 7 make 12, plus 3 plus 2. Okay, then we know that 12 plus 3 is 15, plus 2, and then we know that that is 17. Okay, so that's that side. Now, let's go on the other side and see if we get the same answer. So same thing, 3 plus 5 is 8, plus 2 plus 7. 8 plus 2 equals 10, plus 7, and 10 plus 7 equals 17. So this side equals 17, this side equals 17. Do they have the same answer? The answer is yes to that question. Are they equivalent expressions? The answer is yes. Okay, so that's how you determine if the commutative property works with addition, because no matter what order the numbers are combined in, as long as they have the same ending answer or end result, then you know that the commutative property worked. Now let's try it with multiplication and see if that one works. So 4 times 8 is 32, times 2 times 9. Okay, 32 times 2 is 64, times 9, and I cannot do that in my head, so 64 times 9, that gives me, I got 576, so this one is 576, and now let's do this side. So 8 times 2 is 16, times 4 times 9, 16 times 4 is 64, times 9, and I already did 64 times 9 over here, so I know that this one is 576. So again, going back to our two questions, do they have the same answer? The answer is yes. Are they equivalent expressions? The answer is yes. Okay, so again, commutative property means the property that allows you to change the order in which you add or multiply numbers. Okay, moving on to the next thing. Subtraction is the same as adding the opposite. So we talked about this a little bit earlier, but what you need to figure out is the proof behind it. Okay, so in this one, I am going to use the chip model so that you can help see how it works. So I have 7 positives. So I'm going to put 7 positives. 1, 2, 3, 4, 5, 6, 7. There's my 7 positives. It's asking me to take away, so this means take away 4 negatives. Well, I don't see any negatives on my paper. So in order to get some negatives, I have to add some 0 pairs. So when I add 1 0 pair, I still only have 7. If I add another 0 pair, I still only have 7. If I add another 0 pair, I still only add 7. If I add another 0 pair, I still only have 7. So I've added 4 0 pairs, and my value that is still here is still only 7. But now I have 4 negatives. So if I grab those negatives and take them away, so now they're gone, what do I have left? My answer that I have left is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my answer to this one is 11. Okay? So now I'm going to prove if this works. So in this problem, it says that I have 7 positives. 1, 2, 3, 4, 5, 6, 7. And then I'm supposed to add 4 more positives. 1, 2, 3, 4. And then I see what my total is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Again, I came up with 11. So now let's go back to our statement. Our statement says that subtraction is the same as adding the opposite. Okay? Did we just prove that that was true? So 7 minus a negative 4 is the same as 7 plus 4. Well, we just proved it. So the answer is yes, they are the same. 11 equals 11. Okay? So subtraction is the same as adding the opposite. Okay? And then we have one more thing that we need to discuss very quickly, and that is division is the same as multiplying by the reciprocal. So let's take a look at that one. This one says I have 12 positives. Let's just go with positives because they are positive. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 positives. And it says that I'm supposed to divide it into groups of 4. Okay, so 1, 2, 3, 4. Circle those. 1, 2, 3, 4. Circle those. 1, 2, 3, 4. Circle those. So I divided them into groups of 4. And when I did that, I got an answer of 3. Okay, well now, this one over here is saying that I have 12 positives, but I'm supposed to multiply them by a 4th. Okay, so I'm going to take 12 with a numerator of 1, does not change the value, and I'm going to multiply it because I learned in multiplying fractions that all you have to do is multiply straight across. So 12 times 1 is 12, and 1 times 4 is 4, and now I have a division problem, just like this division problem. So I had 12, draw them out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then I'm supposed to divide them in groups of 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and I have 3 groups, therefore giving me the same answer. Okay, so you can now prove that division is the same as multiplying by the reciprocal, and the reciprocal is of this answer here. So the reciprocal of 4 is 1/4. Okay, that's what the reciprocal is. Okay, so that's all I have to go over with you in your notes today. So let's go back to our goal and make sure that we did it. So our goal for today we are going to use the commutative and associative properties to analyze and create equivalent expressions. Okay, remembering that the associative, because I didn't really talk about it, associative is just when you change your order or your grouping symbols around. So if you change the grouping symbols. And then equivalent expressions just means that one side of the equal side has an expression that is equal to the other side of the equal sign that is the same value as the other side. Question, what are the mathematical operations that can be moved around, making the order of an expression not matter? You learned about 2 of them, so hopefully you remember them. All right, my darlings, that's all I have for you today. Talk to you soon. Bye.